And I would invite Don Walker, please, to come forward to introduce our speaker today.
Good morning. I'm here with my
recording in progress.
I'm here with my grandson, Alex. Alex was born in 1996 in Oxford, England, where his parents were doing postgraduate work at Oxford to get their PhD degrees. Alex's father accepted a position in Glasgow, Scotland, at the Beaton Cancer Research Facility.
Move to your right so that you can see yourself in the.
Okay.
Perfect.
So Alex went to public school in Glasgow, and then he attended the University of Edinburgh from 2014 to 2018. He graduated with a bachelor's honors artificial intelligence first class, and he was the top performer of his year. Alex presently teaches artificial intelligence at the University of Toronto in the Department of Engineering. I've been a member of the PROBUS Club for a number of years, and a lot of you got to know me, and I think you'll find out that after Alex talks to us, that you'll realize that the apple doesn't fall far from the tree. My grandson, Alex Olson.
Thank you so much. I'm just going to get my presentation set up. Yeah,
Screen controls will work.
lots of the mouse.
Yeah.
Maybe it's just touch screen.
Yeah. And
Wait.
you're good.
Good. Okay. Yeah, thank you for that introduction, Grandpa. And hi, everyone. So yeah, my name is Alex Olson. I am here to talk to you a little bit about artificial intelligence. Don't worry, I have a lot of experience in teaching about AI to a really wide variety of audiences. So my goal today is to not have this be a super technical presentation, but instead, hopefully it will help to give you some insight into what actually people are talking about when they refer to AI, which of course is something that we see a lot in the news these days. So, as Don said, I work at the University of Toronto in the Center for Analytics and AI Engineering. It's a fairly new center within the Faculty of Engineering. And basically what we try to do is support research across the entire university that involves artificial intelligence. So a big part of that is teaching, but I also collaborate with researchers really in a wide array of different fields. Basically, if they have an idea where they think that artificial intelligence might be helpful, then they come to us and we help them to figure out exactly what that might look like and how it can be accomplished. So I have papers that I've published that work on things as different as classifying how buildings are constructed, to cardiovascular surgery, to indoor air quality. A lot of engineering, but other disciplines as well. And so with that in mind, I do have a decent bit of experience in talking about AI to people who are not necessarily familiar with it. And that's what I'm planning to do today. So I want to really start off by laying the groundwork and getting an understanding of what AI actually is when we refer to that as a concept. And I think that the best way to understand what AI is to contrast it to a traditional computer program. So I think that some people in this room may be familiar with computer programming already, but hopefully this isn't too boring for you. You can think of a traditional computer program that any computer is using a little bit like a recipe. And what I mean by that is that you start off with a set of ingredients, and with those ingredients, you perform certain steps that are expected to give you an outcome at the end. So it's a very rigid process. Of course, we could deviate from a recipe, but a computer basically has to follow exactly what's going on there, step by step. And there are certain situations where you may or may not do something. So for example, if a soup is too thick, then you might add more water. There's like a conditional there, but it's very rigidly defined. It's a very strict structure that is being followed. And this works really well when we know exactly what is going into a computer program and what is expected to come out of it at the other end. So if we have all of the ingredients that we need, we can follow that recipe exactly as it's written, and we know what we're going to get out at the other end. So this is how, like a calculator would work, for example. There's only so many buttons on the calculator. You know exactly what they are, and you know that whatever comes out is going to be a number that is the result of some calculation. So that's how a traditional computer program works. But as computer science has grown as a field of research, we find that more and more we run into situations where we might not know exactly what the program is going to need to deal with. What I mean by that is that there are situations where the computer might need to be able to handle any number of situations, and some of them might be things that we've never seen before or we've never considered. Language is a great example of this. So, you can construct any sentence you want in English. It doesn't take much thinking to come up with a sentence that's probably never been said before. So how could a traditional computer program possibly be set up to handle all of those sentences? It's just not possible. This is also something that comes up in situations like self-driving cars. While you're on the road, there's things that generally happen, and we could program something, to handle those situations. But really, there's any number of other things that could possibly happen that we can't foresee. So, like a chimpanzee might run across the road, and it's unlikely that you would have written something that specifically handles what to do in that situation. We, as humans, can handle that without too much trouble, right? We can handle new situations, and we can apply what we already know to, decide what to do. But in a traditional computer program, where you have this very strict set of instructions, any deviation from that causes big problems. So that means that with a traditional computer program, we have to think of every possibility that might come up ahead of time. And as we get powerful computers that we're applying to complex problems, we're finding that that's just not really possible. So from there, we can start to talk about what AI exactly is. So at its most simple, artificial intelligence is just a program that can handle situations that the programmers might not have thought of when they were designing the program. In other words, it can handle new situations. So anything where you have to be able to apply understanding that you already have to a situation that you haven't encountered before is where AI comes up. And AI as a concept is actually not that new. So, early artificial intelligence was originally described in the early 20th century, theoretically. And we saw technologies that we would consider to be AI applied even in the middle of that century. So cameras, for example, digital cameras have had face detection for quite a long time, where it can identify where all the faces are in the picture and make sure that they're in focus. That was something that was introduced in the 80s and 90s before the explosion of artificial intelligence that we see today. So hopefully you have a little bit of a sense of how we describe AI as being different to a traditional computer program. It's something where we handle these new situations, but that naturally leads to the question of if normal computer programs mean that we have to think of every possibility, how can we possibly write a program that can handle situations that we haven't described? And there's really two main ways that this is accomplished. One is by what's called rule-based AI, and the other is by machine learning, which is a phrase that you might have heard before. So to talk first a little bit about rule-based AI, This is a technology that has existed in practice for much longer than machine learning. And rule-based AI is where we come up with a set of rules that, when combined in new ways, can be used to figure out what to do in any number of situations. The picture I have here is from one of the first facial recognition systems. Facial recognition, a little bit different from facial detection. Facial recognition is for, is this the same person that we see in these two photographs, or something like that. And so as early as the 1960s, researchers were developing systems where you could more or less automatically identify if two images were of the same person or not. And the way that they did this was by segmenting a face into lots of different parts and then measuring the distances between those parts. And so you can understand that by creating a system like that, where you have these rules, identify the eyes, identify the nose, measure these distances, you can then handle any new face that you come across by just applying those rules. The very first machine translation system, so machine translation is automatic translation from one language to another, was actually created in 1954. And it was able to translate 60 sentences automatically from Russian to English. And they accomplished this using only 6 rules, but a very small number of words. And so because they had a small vocabulary, they were actually able to write out a list of rules that would allow this to be done automatically. And so someone who didn't know any Russian at all would have been able to use that system to translate a Russian sentence into English, as long as it followed these small number of words. So these are all examples of how we can build AI, in these cases, actually without even any computers involved. So both of these systems are things that somebody still had to do by hand, but they didn't necessarily have to know what it was that they were doing. They could just follow these rules and get the outcome that they were looking for. But rule-based AI is something that we don't really see as commonly used anymore. And there's a few good reasons for that. It requires someone, when the system is being created, who has a very strong understanding of the problem, who can accurately describe how to resolve it. So, thinking about the face recognition, there was an expert in facial recognition who had to invent this system and precisely define how to follow all of the steps to make this work. Similarly, in the machine translation example, it was a dozen researchers who had to spend a long time coming up with what these rules were and how they could be applied to translate from one language to another. And so you can see how, in some senses, this isn't that different from just the standard computer programming, where we're following a set of instructions. The challenge is, what do we do when we come to problems that we can't really describe as a set of rules? So, I can ride a bike, I can drive a car, but I couldn't describe to you in 12 rules how a computer could do it. It's just not really possible. It's something that I intuitively understand, but I can't really list out exactly how it works. And that's where machine learning comes in. So machine learning is much newer in its application than rule-based AI. And the way that machine learning works is that we design a system that gets better at a task by being shown repeated examples and being told how to improve. So this, I've got a screenshot here. This is a classic joke in machine learning. It's a person going for a job interview. What's your biggest strength? I'm an expert in machine learning. And you see that they're asked the same question over and over again. And every time their answer gets a little bit closer to the right answer until they get the right answer and then they get the job. And that is essentially how machine learning works, is you show examples and every time the program is a little bit better, it's a little bit closer to the right answer. And as you get those examples repeatedly shown, the performance improves until you get to the point that you want to accomplish. So what makes this really powerful is that, unlike rule-based machine AI, where we are telling the computer how to do something, with machine learning, we actually don't tell it how to do the task. We just tell it, here is a problem, and here's what we expect to see. And the machine learning algorithm is what figures out how to get from that input to that output. And this actually more closely mirrors how we do tasks like driving a car, where we have an intuitive understanding of how to do it, but it's something that we had to learn through repetition, through doing practice, and it's not something that somebody could just tell you in a book exactly how to do. I mean, there's parts of it that you could read about, but overall, the only way to really learn how to do it is by doing it yourself. So with machine learning, we're now able to start to handle these tasks that are too complicated to describe exactly how they're done. In many ways, this is actually similar to how babies learn. And when I did my undergraduate degree in artificial intelligence, one of the things that they made us take were cognitive science courses in the Department of Biology, where they taught us about how babies learn to speak language, because there are connections to how these machine learning algorithms work. And so, you know, for example, when babies are learning to speak, maybe you've noticed this in the past, they will start to use words without necessarily knowing exactly what they mean. They're sort of making a guess, basically, at what the meaning of the word is. And it's through correction or encouragement by parents or by others that they begin to correctly associate those words with the right things. So, you know, a baby might start calling different animals a horse because it knows that the word horse is, you know, generally related to animals, but it's only over time that it starts to refine that definition down to exactly what a horse is. And so that's a similar situation to machine learning, where it's through multiple examples over time that allow the baby to get a better and better sense of what it's supposed to be doing. I'm going to take a little divergence here and talk about this really, really interesting case study that I learned about. I actually learned about this only a couple of years ago. So this is from the world of neuroscience, and I think this is super interesting. One of the neuroscience scientists who did this research actually came and talked at U of T, which is how I know about it. So in 2005, these scientists got a number of participants in, and they inserted probes into these people's brains that could measure the activity of an individual neuron. So just one neuron, and they could see whether it was activating or not, whether it was flashing. And they would then show these participants pictures of many, many celebrities until they found one where when they showed the picture, the neuron would flash, it would light up. And what they discovered is that they could identify individual neurons in a person's brain that would get excited when a participant was shown a picture of Marilyn Monroe, specifically. And what's even more interesting about this is that that same neuron would activate not only when they saw a picture of Marilyn Monroe, but when they read the words Marilyn Monroe, when they heard someone saying the name Marilyn Monroe, these different representations would all cause that same neuron to get excited. And so what that told them is that there's these essentially concept neurons in the brain where it's basically looking at other parts of the brain, it's watching out. And when it sees a pattern that it thinks is corresponding to Marilyn Monroe, it goes, hey, that's what I care about. That's my thing. And that is what then other parts of the brain can look at and understand, well, when that neuron gets excited, I know Marilyn Monroe is what's being discussed. And so this is like a very, very simplified version of how parts of the brain works, but I think it's really interesting, and it helps to motivate what I'm going to talk about next, which is artificial neural networks. But the takeaway here is this concept that we have these neurons in the brain that are essentially watching out for patterns that correspond to a specific thing that they care about. And we have trillions of neurons in the brain. So we have these for all kinds of different things. You know, they used various celebrities and famous people because it was interesting. But the same thing could be said for like a chair, right? There's a neuron that gets excited when you see a chair. So you might have heard this term, neural networks or artificial neural networks, come up in the concept of artificial intelligence. And I'm going to talk about them next. So neural networks are a type of model that is used for machine learning. So machine learning is this broad concept of a computer that is able to learn how to do a task. And neural networks are one method that we can employ to accomplish that. And so they work similarly to this principle of these concept neurons, which is that you have many, many neurons in this artificial network, and each of them learns that it's looking out for specific things in whatever information you're providing. And by building up enough of these neurons in a complex enough structure, they're able to look out for different things and then combine that in a way that allows for very sophisticated behavior or prediction. And so, as it turns out, these neural networks are extremely powerful for accomplishing many different types of tasks. And they broadly form the basis for how artificial intelligence works today, which is part of the reason that some of these terms get used almost interchangeably. So AI, machine learning, neural networks, these are actually different things, but because neural networks are what we're primarily using, they get interchanged a bit. You might have heard of Geoffrey Hinton. He's been in the news a lot lately. He's described as the grandfather of AI. He's actually a professor at the University of Toronto, and his contributions to AI are largely within this field of neural networks. In 1986, he was the person who showed that it was actually possible to teach these neural networks how to perform a task. So the neural networks were actually described theoretically before we even knew that it was possible to train them. And there were many years where people thought, well, these neural networks are cool, but there's nothing we can do with them because we can't teach them. Until Hinton and his collaborators came along and showed that it actually was possible. And that wasn't his only major contribution. He's worked on this for many decades. And in 2012, his lab at U of T published a new approach to computer vision, so computers taking in images that employed neural networks and is actually one of the biggest successes in AI this century. And it's particularly interesting because in this time period between 1986 and 2012, a lot of researchers in computer science had essentially written off neural networks as being not worth investigating. It was sort of considered a bit of a joke at the time because they were seen as just too hard to get to do anything properly. And Hinton was one of only a few researchers who, in that period, kept plugging away at neural networks. He was convinced that this was the right approach. And obviously that did pay off because now they are in just about everything that we use. Despite the fact that they're called neural networks, it is really important to understand that they are not as powerful as an actual brain. Nowhere near as powerful, in fact. This equation that I have here, I don't expect you to necessarily understand this, don't worry. The reason I have it up here is to emphasize that this is what a neural network is made up of. It's made up of mathematical functions. It's not alive, it's not capable of thinking. It's just a highly complex sequence of mathematical operations that we found we can do some pretty incredible things with. Some of the big differences that separate these neural networks from real brains. One is that a neural network is trained a single time and then it's done learning. That's not true of brains. All animals continue to learn literally all of the time. Neurons are being formed, their connections are changing. It's all updating as a result of experience. Neural networks can't do that. When you're using them, they're not changing anymore. So they can no longer update to react to new experiences. It's also worth understanding that neural networks only respond when they are provided with input. So our brains are constantly working, right? Not only are you thinking about things, but there's lots of subconscious things that are happening that the brain is doing to keep you alive. And that means they're always working. Neural networks don't operate like that. They're just sitting completely, inoperative until an input is provided, and then they provide a response. And lastly, an artificial neuron is actually much, much simpler than a neuron in our brains. So an artificial neuron, it looks like that. That's the equation for a single neuron. It's a simple, quote unquote simple. It's simple to me now, mathematical operation. But a neuron in the brain is capable of incredibly complex operations, even just as a single neuron. They can do things like keep track of time. They can consider different situations in different contexts. They're really, really powerful, and these neurons are just not there. So even though artificial neural networks are incredibly powerful, they are not the same thing as a brain. And it's a reason that in our field, people have started a little bit to move away from the analogy to an animal brain. So this technology is quite new, but one thing that I think often surprises people is that they're actually already deeply ingrained in the lives that we lead. So there's a really good chance that you have all interacted with a neural network before you got here today. Google Maps uses neural networks to make its predictions about how traffic is going to change over the course of a day. Amazon uses neural networks to suggest products to you, as well as TV shows if you're using, Amazon streaming. Siri and Alexa and other products like that use neural networks to translate the sounds that they take in into a request that they can actually provide a response to. So all of these things are already using neural networks. Today, researchers have pretty well established that very large neural networks are remarkably good at complex tasks. So Google Translate is an example where machine translation today is a far cry from what it was with that example of Russian to English. They use massive neural networks to accomplish that machine translation. And if you've read about NVIDIA, the company in the news, the reason that their stock is so highly valued now is because they produce the computer components that are needed to allow these massive models to work. And the demand for those components is just, it's exploded compared to what it was even a few years ago. Since 2018, language models, which is the type of artificial intelligence that powers things like ChatGPT, have gone from having around 94 million neurons to over 1 trillion neurons today. So the size of these is just like incredibly expanded. And these models work really well, but the demand for resources is only increasing as these models get larger. And so as a result of that, companies are increasingly interested in how they can make these models smaller or develop components that allow those models to be run cheaply and more efficiently. And so, Apple announced the new iPhone yesterday, the iPhone 16, and a big part of their presentation, which I watched, was talking about how capable those iPhones are of running these models directly on the device. And so they've spent a ton of investment in the last few years researching how they can build computer chips that are small enough and efficient enough to run on a smartphone, but are capable of directly running these neural networks on the phone. And so if you have an iPhone today, there's a good chance that this has a special component that is only designed to run neural networks, because they've been doing this for a few years now. And that allows it to be much faster, and it means that they don't have to send that request off to a computer somewhere else. They can just do it directly on the phone. So that's just how ingrained these technologies are in our life now. I'll just talk about ChatGPT really quickly. I think that, it's something that people are at least familiar with in concept, but I'm going to talk a little about what exactly ChatGPT is. So it's an AI model. It is a neural network, just like these other things that I've talked about. And what often I think amazes people is that the task ChatGPT is designed for is actually only to predict the next single word in a sentence. So all it does is it takes whatever you've written and it says, well, what would the next word be? That's it. Then they take all of the things that you've written plus that word, and they feed it right back into the start of the model. And they say, okay, well, what's the word after that? And they just do that again and again and again, however many times are required until it completes the response that it's looking for. And so, yeah, it's amazing that, this incredibly complex thing is actually doing this, fairly small task comparatively. And the power of this model really does lie in the fact that it is absolutely enormous. So we're talking about trillions of neurons. And it's also trained on a vast quantity of data. OpenAI, which is the company that makes ChatGPT, has long since stopped telling people exactly how these models work and exactly what they're trained on. But when they did tell people about it, which is when the models were smaller than they are now, it was trained on an amount of text that was on the order of thousands of times larger than the whole of the English Wikipedia. So, it's just an absolutely gigantic quantity of text goes into these things. And as a result of that, it's been trained to have a really good understanding of what English words come after each other, which is really all it's able to do. But it's also worth, really emphasizing that what this means is that as powerful as ChatGPT seems, as intelligent as it looks, all it's able to do is predict a single word. That's literally all it's doing. And so you only need to be so fearful of a model that can just predict individual words. It can't do anything outside of that unless you take what it's doing and then feed it into something else or something like that. But hopefully you're getting the impression that I'm not super worried about the future of artificial intelligence. I don't think it's particularly scary, but I'm sure that at least some of you have seen in the news that experts like Geoffrey Hinton have, sort of raised the alarm bells in recent times. And they've talked about why, there's, terminology that gets used like this is an existential threat and things like that. And so I do want to, briefly talk about, what is it that is making people like Geoffrey Hinton so concerned? So really, it's less about the technology itself, becoming, unleashed and going off and creating Terminators or anything. And it's more about the fact that any powerful technology can be used to do harm, right? And so what they're concerned about is the fact that these models are growing really, really quickly, that they're getting more and more capable without necessarily people knowing what the next step in that capability is going to be. And because they're so powerful and they're so, new, there's not a good understanding of how these technologies might be used in the future. So it's less that, they might become uncontrollable and more that we don't know what the implications are of building these technologies without really a plan for the future. There's, of course, a lot of big concern about job displacement, and we've seen this begin to happen already. This is true for any kind of new technology, that it does begin to replace jobs if it's particularly effective. But the concern with AI is that it's happening very quickly, and for a lot of kinds of jobs that seemed like they were quite secure in the past. There's definitely some valid concerns about the fact that the largest of these models are being developed by a small number of companies. So, it's predominantly Microsoft, Amazon, Apple. These huge tech companies are the ones that are doing most of this work. And because of that, there is this valid concern about, what is the future going to look like if we're integrating these models into our lives? But I am still more optimistic than people like Geoffrey Hinton. And, here are a few of the reasons that I think, it's maybe less of something to be concerned about than all of that. The first is that these neural networks and these artificial intelligence models, they're tools, right? Just the same as a calculator, just the same as your laptop. It's a computer tool. It's very powerful. It can do some pretty incredible things. But fundamentally, it's just some complicated math that we can use to make a prediction about something. And because of that, the problem is more about who is using these tools and what they are using them for than it is about the tools themselves. A screwdriver can be a harmful thing, but they're important. We need them. We're already seeing a lot of positive applications of artificial intelligence. I've contributed to research in cardiovascular surgery that is looking at how we can already improve outcomes in heart surgery by looking at previous data and understanding it better than we could in the past. So they're identifying trends in surgeries and methods that, they weren't sure if they were the most effective or if there's something else they should be doing. They understand that better now because of the ways that they can apply AI to analyze that data. So the AI is not doing the surgery or anything, but they're looking at what's happened in the past and they're understanding it. And the other thing is that we're already seeing companies and governments begin to catch up to this technology a little bit. So in the European Union, they have some world-leading legislation that is defining how we should go about building these models and describing what some of the obligations that companies have is to individuals who might be subject to these models. And even some of the companies themselves have taken a lot of steps to recognize that there are these concerns and there are things that they need to do to be cautious and hopefully transparent when they're developing these models. So, looking forward, hopefully you get the sense that hopefully you'll come away from this feeling where I feel, which is that, AI is sort of in between this, dystopian Terminator future and something that is going to go away in a few years. That it is a useful tool, an incredibly useful tool, but it is a tool. And so it's really up to us to decide how this is going to be used and where it's going to be used effectively. I am fairly optimistic that in the future, we are seeing developers and researchers push these things to ends that are productive and helpful for society. And so hopefully, by understanding this technology better, we can make sure that we're actually reaping the benefits of these technologies and not just seeing some of these potential harms. Okay, thank you.
Thank you for that. That was fascinating, I felt. I got an interview of Elon Musk, and he has a company apparently working on artificial intelligence, and he corrected the interviewer. He says, we're not working on AI, we're working on the next generation, which he called AGI, Artificial General Intelligence. And it was a little over my head. His explanations weren't that clear to me. Can you talk about that at all? And how is it different from Sure.
Thanks. And that's a great question. So artificial general intelligence is, it is sort of like the next generation, quote unquote. The distinction here is that artificial intelligence models that we have, like I said, they're trained and then they are finished training and you use them exactly as they are. They don't change after that, right? And because of that, they are built for a specific task and hopefully they're really good at that task, but they can't do something completely different. So like your self-driving car can't tell you how to change a recipe so that it's good for people who don't like cilantro. Humans can do that. We can look at a new task that is something that we've never seen before, and we can learn how to do it. And with enough practice, we can do it well. And so the idea behind artificial general intelligence is that we would be able to build a model that could take a new task that it had never seen before and learn how to do that as well as tasks that it had been trained for. And so that is what people talk about when they're talking about it, like getting closer to a human, is that ability to not just do one task well, but like adapt to new tasks. We are a long, long way from that. I could talk for a long reason about why that is, but the short version is that these neural networks, as they are built, it's literally not possible to make them work that way. So it would require a completely new version of this technology that doesn't yet exist. That's not to say that it will never exist. Obviously, people are working to figure out how that might happen. But at the moment, there's very little progress on that. So maybe someday, certainly not yet.
Another one over here, and I got mine. Okay.
Could you talk about the manipulation of photographs from AI? I'm bothered very recently by, I used to teach a course on London, and I took students to London every other year. Now, I've got on to London tourism promotion. I get all these photographs of, obviously, genuinely trying to get more people to come to London. Now, in the process, they have pictures of the House of Parliament with the London Eye behind or in front. Well, you know as well as I do, this street corner from the Houses of Parliament, they have swans on the south bank opposite the House of Parliament, when you know it's St Thomas's Hospital, I believe. So all these phony AI-generated photographs really bother me, because a lot of people, who are coming from Nigeria or South Africa or something, you don't know the London Eye until you get there. It is not in front of Parliament. So why is tourism promotion doing this sort of job? And I can't stop it. I filled in a little thing, on the phone, but it's a waste of time. Thousands of other people do it, and they don't take any notice of it. And I can't unsubscribe from it. That's another thing. How can I possibly stop these ridiculous photographs? But I'm sure it's happening all around the world in terms of tourism promotion, and it is bad news.
Yeah, absolutely. So this is a big issue. It's something that people have raised a lot of concerns about with elections too, right? Producing fake content about your opponent that makes it seem like they did something or said something that is obviously objectionable. So there is a lot of concern about this. researchers are now very actively interested in this area of sort of detecting or preventing this kind of dissemination of fake content. It's a shame that it's taken as long as it has for that to become something that researchers are interested in. Broadly, it falls into a few different categories. The first is detection, right? So automated detection of this stuff. I am working actually with some researchers from South Korea who are collaborating with us at U of T and also with TELUS, because our telecom companies are really concerned about this. And so we're working on a technology that can detect these images reliably and say, this may be fake, even if it's not obvious to a person. There's also something really cool called fingerprinting, where they can develop these AI models so that the image itself actually contains information that is completely invisible to a person, but readable by a machine that says, hey, just so you know, this is fake. And so the idea there is that even if the person changes the image in some way, like they crop it or they resize it, because they can't see this fingerprint, they have no way of removing it. And thus, other programs, when it gets uploaded or whatever, could see that and then flag it as fake or generated content. And then thirdly is the companies who build these tools that make the fake images have a responsibility to restrict or at least consider what it's possible to create. And so, for example, Apple has been releasing all of their own stuff very recently. They have an image generation tool. But one of the things that people have remarked on is that very conspicuously, the Apple tool does not let you create a photorealistic image at all. You can create a cartoon, you can create, other styles like a painting or whatever, but there's no functionality to create a photorealistic image. And so it's obvious that people at Apple have thought about this and they've said, the easiest way to prevent that happening on our system is by only allowing people to create content that is clearly generated, or at the very least, made by an artist.
Another question.
Could you comment on any emerging medical applications such as devices for people with limited eyesight? I think there's some work going on in that. And then secondly, on a topic that we're likely more familiar with, self-driving cars.
Yeah, so when it comes to limited vision, the thing that's really exciting that I've seen is the combination of computer vision with chatbots like ChatGPT. And so you can now buy glasses that have a camera in them, and they're web connected. And if you're low vision or if you're blind, you press a button and you say, what am I looking at? And it takes a picture, and the model is then able to describe exactly what you're looking at. But more than that, because it's got this chatbot, you can then ask like a follow-up question. So let's say you're looking at an aisle in the grocery store, you take a picture, it says you're looking at pasta. Then you can follow up and you can say, well, where is this specific pasta? And it can say, oh, it's on the third shelf to your left or whatever. And so the combination of the fact that it can see what you're seeing and also have a conversation means that it's incredibly useful for people who have low vision or no vision. And that's essentially available today, which is really amazing. What was the second part of your question?
Self-driving cars.
Yeah, self-driving cars. I think that we are a very long way away from it being able to do 100% of driving. Personally, I actually think that may never be possible. What it is very good at now is driving in certain contexts. So like on the highway, for the most part, that is solved now. As long as you understand the lanes, you understand the cars around you, there's not that many unusual things that can happen. And so it's able to deal with that quite well, including things like switching lanes and navigation. The challenge comes when you're on like city roads or country roads where there's way more possibilities of what can happen. And the risk is that if it doesn't know exactly what to do in an unusual situation, that could actually cause danger. So I think that there's a lot of active research into that, but we're some time away from it working as well as in those limited contexts.
As I walk to the next question, Alex, somebody started the in-meeting questions. Is there anything, I can't read that from here. Are there any questions there? And then Glenn has a question.
I don't see any questions up here.
Okay, that's fine. Thanks.
Glenn has a question.
Yeah, thanks for that, Alex. That was really educational. I have this impression, and I'm probably totally wrong, that the marketing people have got a hold of AI, and they're calling all kinds of things AI that really aren't. Can you comment on that?
You're absolutely right. And it's actually very frustrating to some of us as researchers. Yeah. Because it's very popular and exciting right now. There's a lot of pressure to describe things as, AI or AI capable or whatever that are essentially exactly the same as they were, 5 years ago. Sometimes that's because they actually do use AI, but it's sort of like the less exciting kinds of AI. So, like I said, AI is really anything where you can handle situations that you might not have seen before. And there are lots of programs that have been doing that for 10 years. So it's completely possible that they're being truthful that it's using AI, but that they're sort of misleading in that it's not doing anything new. It's just that they've looked around and they've said, hey, we can call that AI. And so they are.
And another question here, but also one as I'm looking. I noted that you mentioned, of course, I really hadn't thought about this. ChatGPT is trained in English. So that means that ChatGPT doesn't speak German or French or Dutch or Italian. Are there parallel developments in those other languages and feeding them trillions of pages of text in those languages?
Yeah, so the big challenge there is getting the amount of text that's needed. So, obviously the vast majority of the internet is in English. And that means that when they created ChatGPT, compared to other languages, they could just pull all of that English stuff and train it on that. But for other languages, as you go down the list, there's vanishingly smaller amounts of text available. So by the time you get to, Gaelic or something, there's just like not the scale of text that's needed to train those languages. So China, as you might expect, they've got language models. Theirs work very well as well, because there's tons of text that they can look to. There's some French ones, things like that, but Spanish, things like that, they are very much catching up when it comes to those technologies. There are efforts to create models that can take what they've learned in English and apply it to another language. And that is sort of the hope for languages that are much smaller, is that they can start in English and then learn to speak in
How much AI is involved in the elections?
Sorry, can you repeat
Votes, like election votes.
what do you mean, sorry?
Is there anything that goes on in the?
No, especially not in Canada. They're very, very cautious about introducing those technologies. The only place where there might be artificial intelligence used is after the election has been held to check that there's no irregularities. So, completely after the fact, they can use AI to see, is there anything that is not what we've expected? And then that gets flagged, and then that would be looked at by humans. So the AI would only be just, raising, that's something we should look at.
So actually, it's a benefit.
Yes, exactly. But I would completely say, like, let's not put it in the actual votes. Never. Yeah.
Thank you. Alex, first of all, your knowledge of the subject is extremely deep, and we thank you for sharing a little of that with us. I also wanted to explain, we actually have done PROBUS AI. Okay, we had your grandfather send us a gazillion pieces of information on you. And we put it into our Neutron AI PROBUS and asked what thank you gift would Alex like the most. And it came up with a thank you $30 gift certificate at LCBO, which we know is very
Very good knowledge.
Yeah.